When we're naming alkanes, here are the modifications that need to be made for non-hydrocarbon substituents. Here, HC means hydrocarbon. Firstly, the longest chain must contain the substituent. Here are some example substituents: nitro, amino, fluoro, bromo, iodo. If we had a Cl group, that would be a chloro group. And there are other substituents. Phenyl we'll meet later, but here are just a few of them. Secondly, we number the chain carbons starting with the end nearest a substituent. A non-hydrocarbon substituent takes precedence over a hydrocarbon branch. Thirdly, name and give the numbered location of each substituent, and if necessary, choose numbers so that their sum is as low as possible. So let's give you a few examples. For this first one, it ends with hexane, so I'm going to draw 6 carbons in a chain. Then off of carbon number 3 we have a bromo substituent, and off of carbon number 2 we have a chloro substituent. And it doesn't matter if I number these chain carbons from the left or from the right, as long as we're consistent, it doesn't matter. Let's try the next one. Here we're given the structure, so we need to name this. This is one where we run into the case where a non-hydrocarbon substituent in the lower left here, these iodo substituents, are connected to this carbon here, which means that this carbon must be a part of the longest chain, even though these 2 carbons up here will then not be in the longest chain. We could actually form a longer chain of carbon if we started here than if we started here, but because the non-hydrocarbon substituents have to be hanging on to the longest chain, we have to start with this carbon here. If we count those, we have 7 carbons in the longest chain, starting with number 1 here and number 7 over here. We numbered this one 1 because that means we're going to have some substituents hanging on to carbon number 1 and this ethyl group hanging on to carbon number 2. If we had started numbering from the right, then those substituents would be hanging on to carbon number 1, 2, 3, 4, 5, 6. This ethyl group would be hanging on to carbon number 6, and these iodo groups would be hanging on to carbon number 7. 1 and 2 are lower numbers than 6 and 7, so we need to number, in this case, from this carbon right here. This ethyl group is first alphabetically compared to iodo groups, so we need to say 2-ethyl. And then we have 2 iodo groups, both of which are hanging on to carbon number 1. And the way we represent that is by saying this right here, 1,1-diiodo. We put 2 1s there because both iodos are hanging on to carbon number 1. We say diiodo because there are 2 iodos. I use this example specifically to show you that this di that we put in here does not affect the alphabetizing of the substituents. Because you might think, oh, yes, ethyl comes before iodo, but diiodo would come before ethyl. Nope, this di prefix, and if we had 3 iodines, we would use the prefix tri. That prefix, di or tri possibly, does not affect the alphabetizing. Let's try the next one. 2-methyl-1-nitrobutane. It ends with butane, so I'm going to draw a chain of 4 carbons. Off of carbon number 2 we have a methyl group, and off of carbon number 1 a nitro group. Whenever I draw a nitro group, which is shown here, or an amino group, which is NH2, I like to draw the bond pointing towards that nitrogen atom, because that nitrogen atom is actually the one that's hanging on to the carbon chain. Let's try this last example. Here again, while the longest chain actually kind of seems to start down here in the lower left and move up and then to the right. Because we have a non-hydrocarbon substituent right up here, then that carbon has to be part of the longest chain, which means our longest chain is just going to do the zigzag thing. And this part down here in the lower left is going to be a substituent group. It'll be a propyl group. If we count the carbons, 1, 2, 3, 4, 5, 6, 7, you can see in the lower right corner we've got heptane, and then we have 3 substituents. We have an amino group, we have a propyl group with 3 carbons, and then we have a nitro group. Which of these carbons, the one on the left or the one on the right, is carbon number 1? And the answer is, wherever we get to a substituent first, as quickly as we can, that should be carbon number 1. Well, it's the same, because whether we number from the left or from the right, we get to a substituent at carbon number 2. Then what do? Then we want the sum of the substituent numbers to be as low as possible. So if we number from the left, this substituent will be attached to carbon number 2, this one to number 3, this one to number 6, which is a smaller sum than if we number from the other side and we say 2, 5, 6. So then we have to put these alphabetically. 2 amino, amino comes first, 6 nitro comes next, and 3 propyl. What if we have cycloalkanes? As the name would suggest, cycloalkanes form a complete loop of carbons. And when we have cycloalkanes, we need to use the cyclo prefix before the ane part. Let's try these. This structure here shows 6 carbons in a closed loop, so we need to use cyclohexane, and then we have an ethyl group that's hanging off, so this one is called ethyl cyclohexane. Just for fun, if we were trying to count how many atoms of each type in this molecule, clearly we have 6 carbons in a ring, and here's number 7 and number 8, so we have 8 carbons, and then there are hydrogens hanging off, and I've put dots in here to show where those hydrogens are. Remember that each carbon has potentially 4 hands, so any hands that aren't shown are understood to be holding on to hydrogens. If you count the hydrogens there that I've shown with dots, you would find that there are 16 of them. And of course, we don't show the dots whenever we draw the structure, so those are going to disappear. How about the last one? It ends with cyclopentane, and then at the beginning we have 1 bromo, 1 chloro. So we have a bromo and a chloro substituent connected to the same carbon. And then off of carbon number 2 we have a methyl group. Now it doesn't matter whether the one on the left is carbon number 2 or the one on the lower right is carbon number 2. As long as it's next to carbon number 1, then we'll be fine. And if we were writing the chemical formula for this, we would count 5 carbons in a ring plus a 6th one. Obviously 1 bromine atom, 1 chlorine atom, and I'm counting 10 carbons there. Let's summarize. In this lesson we went through how to name alkanes that contain non-hydrocarbon substituents. The biggest ideas are: 1. The longest chain must contain the substituent. 2. You number the chain carbons starting with the end nearest a substituent. A non-hydrocarbon substituent takes precedence over a hydrocarbon branch.